Hi, welcome back to my video lecture series on data mining, and today we are going to discuss about data objects and attributes. So my name is Dr. Chiranjeevi Manike, Professor and Head of Data Science and Cyber Security Department, MLR Institute of Technology, Hyderabad. So it is very important topic for the data scientists and who want to apply the data mining algorithms, who want to visualize the data. So they should know before applying any kind of data mining or before applying any visualizations or any pre-processing also, they should know about the data. So it is very important to know what are the different types of data we are dealing, what are the possible values. So it is very important lecture. So let us discuss what are the concepts we are going to see in this video lecture. The first we are going to discuss introduction about the data sets, then what is an attribute, and then based on the possible values of attributes we are going to discuss about nominal attributes, ordinal attributes, binary, numeric attributes, and then we also discuss the discrete and continuous attributes. So let us see what is a data set first, because in almost all data science field and the data mining professionals, data scientists, and who are working as a database professionals also, they should know, they should have an understanding about the data sets. So what do you mean by data set? So that is the data set is which is the most frequently used term in the literature of data science, data mining, data warehousing, etc. So what do you mean by a data sets? So data sets are made up of data objects, and the data objects represents an entity, and then the objects are typically used to describe an attributes. So let us take one simple example here, that is, this is a data set. So this is one data set. So this data set has rows, and these are the rows of this data set, and it also has the columns. So these are the columns of this data set, and these columns are nothing but attributes which are used to describe the data set, this data set. And we have the rows, like each row that is an observation. Okay, so each row shares, like we can say it is an object. Each row is an object that is described by the characteristics like name, ID, class, marks, gender, etc. So you can see this all like 1 to 10 records or 1 to 10 rows. This all shares the common attributes or common attributes which are used to describe the objects like ID, name, class, etc. So this is one best example of a data set. So then what is an attribute? So the nouns we use, attribute is used to describe an object, and we use the different names like attribute, dimension, feature, variables. These are all interchangeably used in the literature. Mainly the dimensions are used, this is used in a data warehouse mostly, and the features we use in the literature of machine learning, and the variables that are used in the statistics, etc. And the observations, like if you go back to the previous slide, and these are the observations, like, so there are some attributes. For each attribute we will collect the data, and those are called as observations. So each attribute, or we use the set of attributes to describe an object. Like in the previous example, like, or let us take a student is an object, and the student is described with attributes called as the ID, or let us say the roll number, and the name, and year, I mean second year, third year, final year, and section, and discipline, etc. So these are all the set of attributes are used to describe an object called as a student. Okay, so like suppose if you want to prepare a data set for the students, Then we will select this set of attributes, and for each student we collect the ID, name, years, section, discipline, etc. So each student details will be observations, right? So this set of attributes like ID, name, year, section, discipline, these are called as those are used to describe an object. These are called as a feature vector or attribute vector. And then the number of variables involved in a distribution of data, that depends on, that is divided into the univariate and the bivariate analysis, and also the multivariate analysis. Suppose if the data distribution involves a single variable, and that is a univariate analysis. If two variables are involved in the data distribution, that is called as bivariate analysis. If more than two variables are involved in the data distribution, that is called as a multivariate data analysis. And then the another very important thing, that is based on the values, right? The possible values, we will understand what kind of that attribute, or what is the type of the attribute that belongs to. So the type of an attribute, that is determined by a set of possible values. So let us take an attribute called as a name, right? So name of the student object, right? The name is one attribute that is used to describe the student object, and this attribute takes the set of possible values, right? All the names. And let us take another like age. Age is another attribute that is also used to describe a object like a student, a customer, or any employees, etc. So age would take the possible values, like suppose some 30 years, so 40 years, 20 years, like that. So these are all the possible values which are accepted under this for this attribute age. So like for each attribute is going to have set of possible values. So based on the possible values, that attributes are divided into the different categories. So let us see what are the different categories of attributes. So these are the different categories of attributes. These attributes are mainly categorized based on the qualitative and the quantitative nature. The qualitative category we are going to discuss like a nominal attributes, then binary ordinal attributes. Under the quantitative category, those are also called as a numeric or the continuous. We are going to discuss about the interval scale and the ratio scale attributes. So let us see what do you mean by a nominal attribute. So nominal attribute means it represents the categories, states, or the names of things. So these are also referred as a categorical. Like suppose let us take a university database, and if you take the designation, so designation attribute, it would accept the set of possible values like professor, associate professor, assistant professor, like this. So these are the categorical variables that nominal attributes deals. And then another property is the mathematical operations and values of nominal attributes are not meaningful. It makes no sense of subtracting, like suppose the customer or a student ID. Okay, student ID, right? We cannot subtract the student IDs from the another ID. It makes no sense. And then the second category under this, the qualitative attribute, is the binary attribute. The binary attribute is also one of the nominal attribute, but only the difference is there are two categories or the states in this binary attribute, that is 0 or 1. So 0 is used to represent the absence, and 1 is used to represent the presence. Like suppose if you take a medical test, let us say the 0 represents a negative report and 1 represents the positive report. Okay, so these are the examples of the binary attributes. And the binary attributes represents only the two states like a true or the false. Then those attributes are also called as a Boolean attributes. Next one is the depends on the outcomes of the states, that is the weightage given to the outcomes of the states. The binary attributes are again categorized as a symmetric and the asymmetric binary attributes. So let us see the symmetric. What do you mean by the symmetric attribute? So outcomes of the states are equally valuable, like let us say the gender. So gender attribute, like suppose if you represent as a binary, then for the male we use some 0, like let us say for male we use 1 and the female we use 0. Okay, so both the values, like both the states 1 and 0 are given a equal importance. There is no difference in the weightages. Both the states will be given a equal weightage. So in that type of binary attribute is called as the symmetric binary attribute. And whereas the second case, that is asymmetric, that means outcomes of the states are not given equal importance. The best example is medical test. Okay, so the medical test, sometimes some medical test like the positive and the negative medical test would be given the different weightage. The positive will be given the more weightage than the negative report. Okay, so this is one best example of a asymmetric binary attributes. So next one is ordinal attributes. The difference between the nominal and the ordinal attributes is we can order the values of these attributes. Mainly the ordinal attribute is an attribute with possible values that have a meaningful order, and that is also we can rank among them, but the thing is we don't know the magnitude between the successive values. Like suppose let us take one simple example, like if you take the size, and that we measure like we mention like a small, medium and large. So we don't know the order of the magnitude of the difference between the small, medium, the medium, large, the small, large, etc. Similarly, if you take the grades as another example also, like A, B, C, D, A plus, B plus. So we can order these grades, but the magnitude of between the successive values is not, does not make sense. And next, another best example like a customer satisfaction survey, and this is the example of ordinal attributes. So we can order this like extremely, very, moderately, slightly, not at all, etc. But we don't know the magnitude, the difference between the extremely, very well, etc. So then we can also obtain the ordinal attributes by another technique that is called as a discretization, right? So discretization of the numeric quantities by splitting the value ranges into a finite number of ordered categories, we obtain this ordinal attributes. Whereas nominal, the main difference between that we will discuss at the end. Yeah. So next one is the central tendency of an ordinal attribute can be represented. Central tendency like a mean, median and mode. So the central tendency of ordinal attributes can be represented by its mode and its median. That means the frequency. We just find out the frequency, like how many small, how many large, how many medium, etc. And we also find out the median. Okay, like suppose if you take the medium, small, medium and large, and median is a middle value. So we find the central tendencies like the mode and median, but we could not find the mean, okay, to this ordinal attributes. And the numeric attribute is another quantity, that is, it is a measurable quantity that is represented as integer or the real values. So the numeric attributes are categorized into the interval scale attributes and the ratio scale attributes. So what is a interval scale attribute? Interval scale attributes are measured on a scale of equal size units. So let us say like age we mention like in terms of equal size units, like some 10 to 20, so 11 to 30, so age we can represent in terms of interval scale attribute like 10 to 20 years, so 21 to 30 years, 31 to 40 years like this. This is one best example of interval scaled attributes. And similarly the temperature like some 15 degrees Celsius, some 20 degrees Celsius, these are the temperatures. So we will find out the difference, we will find out the magnitude or difference between the values. Like suppose here we can see like the 20 degrees Celsius is 5 degrees more than the previous. Let us say this is the previous day temperature and the 20 is a present today's temperature. Then we would say that today's temperature is more than 5 degrees Celsius of the yesterday's temperature. So this is one the best examples to understand the interval scale attributes. And the next category is the ratio scale attributes. A ratio scale attribute is a numeric attribute with a inherent 0 point. Okay, so one best example like a kelvins. Okay, the Kelvin that is twice as the 5 degrees Kelvin. And there are some other examples of this ratio scale attributes like the count attributes such as the years of experience. In this case the object would be the employees, and then the number of words, and in that case the objects are the documents. So these are the examples of a ratio scaled attributes. And then we have like a discrete and a continuous attributes. This is very important one. So mainly in machine learning we used to deal with the different the types of attributes which are like discrete and continuous and categorical. Mainly in the classification approaches we most of the times we used to deal with the categorical data. So let us see what is a discrete and what is a continuous attribute. So discrete attribute has a finite or the countably infinite set of values, so which may or may not be represented as a integers. For example, let us say like number of cars. Okay, so number of cars you have, I would say like I have 1 car, I have 2 cars, I have 3 cars, like that. But I could not say like 1.5 car. Okay, so this is not a discrete attribute. This is not a value, right, which belongs to this discrete attribute. And for example, let us take another that is which is not a discrete attribute, then that will be a continuous attribute. So they will be having a decimal point. Like if you take weight, height attributes, the weight would be measured in terms of like some 30 kgs, 30.5 kgs, okay, some 40.2 kgs, like this. Okay, so these values would be represented within the range. Like suppose I would consider the values, set up all possible values within the range from 1 to 110 or any, right, within the range. And like similarly another attribute like a height also would be represented like this, 120.5 centimeters, right, 130.2 centimeters, like this. So these are all the examples of continuous attributes, and these are like the integer type. Okay, mostly we use the integers to represent the discrete attributes, like number of cars and number of children you have, like I would say 1 or 2, 3, like that. Okay, so these are the about different types of data and the categories, etc. So before we end up the session, let us summarize what we have discussed here. So we discussed mainly what is a data set, because this is one of the most frequently used term in the data science and data analytics, etc. We used to call as a data set simply. So the data set, what is data set? And then the data set is, again, it is a collection of objects. Okay, collection of objects, and the objects are described with attributes. Objects are described with attributes, and then this attributes based on the possible values. For each attribute would accept the possible values, So based on the possible values, the attributes are divided into the different categories, like nominal attributes, ordinal attributes, then we already discussed about nominal attributes, ordinal, and the numeric attributes, etc. And then the binary attributes, like if it takes the two possible values like states like 0 and 1, etc. So it is very important to know about data before we proceed or before we apply any kind of data mining, data science or algorithms. So thank you for watching this video. So we will come up with the next video in the next session. Thank you.